So you probably watched my video with doing this the tree diagram, so I decided I better try a different approach. So one thing I asked myself is what am I looking for actually here? Well, they told me, let's see, so they told me, let's write down some probabilities. They told me that the probability that somebody catches the virus is infected is 1 out of 200. They told me that the test, let's see, they told me the probability of somebody testing positive, let's see, positive test, given that they have the virus infected, is equal to 0.8. So I'm going to write it as a fraction. This is a decimal 0.005. This is 0.8. Then they told us that the probability here, then they told us the probability of testing positive. So the probability of a positive test, given that they're not infected, is 0.1. So that's all the information they gave us. And then what they're asking us for is, for A, what's the probability that somebody has the virus, so they're infected, given that they had a positive test? See how that's reciprocal of that? And then for part B, can I select everything here? Come on, give me everything. No, I guess not gonna. For part B, they're asking us what's the probability that somebody's not infected, given that they test negative. So if you watch, I probably said this already. If you watch my tree diagram method, that certainly works for adding them up, but that's not what Dr. Stevens does. So I'm trying to make this so it's compatible with what he's doing. So here's how I decided to do this for this video. So I created a table that said, okay, so this is kind of like the RH positive, RH negative, and type O blood type one in the textbook, or even the ski pass, no ski pass one. So that doesn't use conditional probabilities. So what I did is I wrote the rows I wrote tested positive, and then tested negative. Then on top I wrote infected and not infected, not infected. Okay. And then I said, well, what if we start with, I mean, that whole 1 out of 200 people? I said, well, what if we start with 200 people? We're going to fill out a table. That would mean that there was only one person infected and 199 not. But if 80% of those people, what did it say? 80% of those people that test positive are infected. So this one would be 80% of whatever this is. Well, that's a decimal. I didn't want to do that. It didn't make sense to me. So, well, I mean, I probably could have made it happen, but I didn't figure anybody who I was explaining this to would work. So I increased this. I said, hey, let's go to 200,000 people. So that meant if 1 out of 200 of them are infected, I'm just going to divide that by 200, and I got 1,000 infected people. That would mean, that doesn't decrease, that doesn't delete either. Let's see if I can just delete that. Okay, good. So that means there's 199,000 people. Is that right with my table? Yeah, 199,000 people that are not infected. Now we can start applying those ideas. If 80% of the people that are infected test positive, that means there's 800 people that are positive and infected. That would mean 200 people would be testing negative, but they're also infected. So we're missing, the test is missing those 200 people. Now, how about not infected? So then they told us that the probability that somebody testing positive, but they weren't infected, was 10%. So 10% of so wait a minute here. They're not infected. So the probability, would I write that? The probability, yeah, the probability that they get a positive test given that they're not infected. I'm only going to be concerned about this group of people. So 10% of those is, I'm just going to make 19900, knock off a zero, right? So we're pretty good there. And then if I've got 199,000 people that are not infected, and I got 19,900 people that are testing positive, that means we have 179,100 people that are truly negative and testing negative, not infected and testing negative. Okay, so this column adds up to 1,000. This column adds up to the 199,000. Now we're going to go across and get the row totals. This will be the number out of the 200,000 people, how many people tested positive. So we add those and together, and I got 20,700 people tested positive, infected or not. And then the next column down, well, actually what I did is I took that away from the 200,000. I didn't add across, but I could have. Maybe it would have been easier to do that now that I look at it. So that would have been 179,300. So got my table all filled out now. Now we should be pretty easy to, it should be pretty easy to get this to work. Here, let me see if I can't do some deleting here. I don't want to delete that. I don't want to delete that. Okay, I'm gonna select everything. Whoops, I want to select everything. Just tap on it. Okay, so I'm gonna tap. I think that's all selected. I just lost my 800 here. Can I shrink it? Oh, I can. Here we go. Yeah, we'll just make the 800 look big. This is a great piece of software, but I don't know how to remember how to use it. So I'll leave that there. So the question A is asking me, where did I write this? Question A is asking me, what's the probability that somebody's infected given that they test positive? So because this is a conditional probability, I'm only looking at the tested positive. That's what the given is, right? These are the group of people we want to look at. So whereas I'm seeing 800 people are positive and they are infected and tested positive, divided by the 800 divided by the 20,700. Well, if you punch that into a calculator and multiply it by 100, I got the 3.864 blah 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 blah. Okay, so that it checked with what my open math was saying. Okay, does that make sense? How I set up the table and then I knew what to divide. Okay, so let's move this. Let's do this. Select just those things. Come on. Give me a minute here to learn what I'm doing. So then for part B, that's looking for find the probability that somebody does not have the virus, not infected, given that they test negative. So in that case, we're looking at this row. Those are the people that tested negative, and They aren't infected, so that probability will be 179,100 divided by 179,300. And that, I did it divided, I got the 99 point, and times it by 100, of course. I got the 99.88, blah, 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 blah. Okay, so we can certainly talk about it when we meet, but this is probably the other way I'm going to show you, and we can go over it if you need to. I just wanted to record this while this is fresh in my brain.